In this presentation, I will explain the function of transformer cores and their construction. Additionally, I will outline the functions and limitations of an autotransformer. If you have not completed the Transformers Part 1 presentation, you might find it helpful to view that lesson before this one. Before we begin, let's review basic transformer anatomy. To begin, we start with a coil of wire. Near the first coil, we place a second coil. This second coil is electrically insulated from the first coil. Electricity cannot directly pass from one side of the transformer to the other. To the left of the first coil, we connect a power supply, in this case, an AC generator. This coil is called the primary coil being the coil connected to the supply of power. The remaining coil is connected to a resistor or device being powered. This second coil is called a secondary coil and will be not connected to the power supply. It will be connected to the device being powered, like a light bulb, a motor, or in this case an X-ray tube. The primary coil is an electromagnet that has a collapsing and expanding magnetic field surrounding it. Early on, it was discovered that electromagnets could be made more efficient by placing a ferrous, iron-like metal bar down the center of the coil. Addition of the metal bar down the center of the primary and secondary coils makes transformers more effective. More of the electrical energy used to power the primary is transferred to the secondary side of the circuit. The most inexpensive and least efficient transformer consists of two coils of wire held close together. This transformer is called an air core transformer. Adding a ferromagnetic bar down the center of each coil increases the efficiency of the transformer and the cost of manufacture. In this type of transformer is called an open core design. Connecting the ends of the cores further increases the efficiency of the transformer and is called a closed core transformer. The most efficient type of transformer core is a shell design. The shell core looks like a box with a post down its center. The primary coils are wrapped around this center post. And the secondary coils are also wrapped around the center post as well. Both sets of coils are electrically insulated from one another. Of the four types of core designs, shell type is the most expensive to produce. Even with cores, not all the energy input applied to a transformer is transferred from primary to secondary. Loosely bound electrons in the core material can whirl around, forming eddy currents. Eddies are electron whirlpools that circulate around the core material. Eddy currents cause an unwanted heating of the core material itself. A secondary form of energy loss is called hysteresis loss. Hysteresis loss is caused by the atoms of the core material flexing and rubbing against one another. And this rubbing action produces heat. We want our transformer to perform its intended function of controlling voltage, not producing heat. A simple design change in the construction of a transformer's core can minimize eddy current loss. Instead of making the core from a solid block of metal, we construct it from a series of thin metal plates or laminations separated by insulating material. In the large block-type core transformer, electrons are free to circulate. Constructing the core from thin lamination provides a physical barrier to this circulation, and the whirlpools are less able to form, reducing energy loss due to eddy currents. To deal with hysteresis loss, a different strategy is used. If the core metal is soft, the atoms can move more easily and rub against one another as the magnetic field moves through them, causing heat to be generated by friction. So, by making the core metal hard, the atoms in the metal are less able to move against one another. And less movement means less of the transformer's energy is converted to heat, and more of the energy is transferred from the primary to the secondary. To make the core hard, a silicon steel is used to construct the core material. There is a transformer that consists of a single coil of wire. It is called an autotransformer. In this example, the primary is connected to coils 1 through 8, and the secondary is connected to coils 1 through 11 via a rotary switch. If the switch is connected to coil 7, the transformer will act as a step-down transformer. On the other hand, if the switch is connected to coils 9, 10, or 11, the autotransformer will act as a step-up transformer. Autotransformers are mostly used to make a device that can offer the user a selection of voltages. Autotransformers are limited to stepping up the voltage by a factor of 2 times and are generally used to provide kV selection in the X-ray generator. The kV selector autotransformer is in the circuit before the voltage is stepped up to kilovoltage levels. To summarize, the addition of a core to a transformer can make it more efficient. The core types are air core, open core, closed core, and shell type design. Generally, the addition of a core and its design affects the cost of a transformer. Transformer cores are constructed of laminations of hard silicon steel to minimize power loss through eddy currents and hysteresis loss. This concludes part 2 of Transformer presentation. Thank you for your attention.